started. So what we're looking at first today is writing an augmented matrix. So a matrix is a system, an arrangement of numbers. The dimensions of the matrix with m rows by n columns. Rows are going to be going left and right, and columns are up and down. Now the way we read it is the number of rows by the number of columns. So rows by columns. So if we look at this here, matrix A is a 2 by 3, and each element is the number in the matrix. So each one of these numbers here is an element. Each one signifies its own element. Now, 0 is considered an element, so just because it is a matrix of all zeros doesn't mean the matrix is 0. It's just a 0 matrix. A matrix derived from a system of linear equations, each written in standard form with the constant term on the right, is an augmented matrix of the system. For example, the system below can be represented by an augmented matrix. So if we look at this here, it's not listed there because I covered it up. But this matrix, you don't have to write this down. We will be working with these. X, Y, Z, constant term. X, Y, Z, constant term, our number. X, Y, Z, our constant number. Is written as an augmented matrix where we remove the equal sign and the variables. So the top one is 5, 3, negative 2, 1. 5, 3, negative 2, 1. Our second one, 1, 2, 3, negative 1. 1, 2, 3, negative 1. The bottom, 3, negative 4, 1. 3, negative 4, 1. And the constant term, 10. This here would be an augmented matrix. So this first example here, we want to work on writing this as an augmented matrix. Now we want to have X first, then Y, then our constant terms. Well, the second equation, X plus 3Y equals 12, that's X, Y, constant term. But is the top equation in that form? No. So we just need to switch the 2x and y. If I switch that, I'll have negative 2x plus y is equal to 1. I just needed to switch those two terms. Now, because it's minus 2x, that negative is connected with the 2x. So it stays negative. So we have that taken care of. Any questions on this here so far? Now to write the augmented matrix, we're going to take the numbers in front of each variable. So what's the number in front of x? And then 12. Our next one. Congratulations, we've written an augmented matrix. Now, what are the dimensions of this matrix? Almost. Because we're going to go rows by columns. Down, over. Rows by columns. So the dimensions are 2 by 3. That's it. That's all we're doing with this. Yeah, because write an augmented matrix, did it, state the dimensions, done. All right. Well, if we look at this first equation, we're going to have to change it because they put y first. So we need to switch it. So we can just say 4x plus 3y is equal to 13. So we're not looking at that one anymore. The one on bottom is already set up with x first, then y. So we can go on and write our augmented matrix, which would be 3, and then the bottom would be and the dimensions would be 3 by 3. And that's it. That's all we have to do for this here. Questions on this here? Okay, so now we have a 3-variable system of equations, and we want to write it as an augmented matrix. Now we need all the variables on the same side, and we normally want to put it x, y, z. So is there one of these that we need to change? First one. So how do I need to change it? Well, if I can write. I'm going to write it out here to the side so we can see how it's changed. What do we need to do to change it? So, like the last ones there, we had all the variables on the same side, yes? What's wrong with this one? Z's on the right with the constant term, yes? So we need to move it to the other side. So we can do that by adding 2z to both sides, which will give us 3x minus 4y plus 2z is equal to 7. We aren't looking at that equation anymore because we have it fixed. Any questions on this here before we write the augmented matrix? Okay. So let's start with this top equation. So we would have what? 9. Y 0. Yep. Because we have x, y, z. So I need a spot, first spot, we denote it as for x, because this first column is x, because all those values are going to be x. The second one is our y's, and the third one is our z. If there's not a variable there, it's considered to be 0. We have to fill it in. The next one would be 2, 4, -1, and last is 3, -4, 2, and 7.
We need the following students to report to the computer lab for pictures. Leah Martinez, Kate Tutton, Leah Kendall, Rachel Clemens, Austin Deason, Kaden Mitchell, Ian Williams, Jacqueline Clinton, Tony Perez, Tanner Rebus, Abe Wilson, and Amy Kinchelow. Thank you.
So what are the dimensions of this here? 3 by 4. And that's it. Questions on this here? We good with this here? No. Because when we talk about doing or solving these here, we can actually flip these equations. We can flip them. So the order in which we put them really doesn't matter. But we do need to make sure that the variables are all lining up in the same way. So if we have x first and 1, all the x's have to be first. Now looking at this one here, is there anything we need to do to any of these equations for our augmented matrix? Well, the top one is x, y, z equals number. Next one, x, y, z equals number. X, y, z equals a number. So there's nothing we need to do to any of these because they're already set up in the way that we need them. Yes? So the top row would be what? 3 by 4. 3, 4. 3 rows, 4 columns. Questions on this here? There will be some of the problems on this here. Do we need to see another example of writing an augmented matrix and stating the dimensions? We feel good with this here? Solving systems of equations with technology. Many technology tools have matrix features that you can use to solve a system of linear equations. The augmented matrix in example 2, rewritten in reduced row echelon form, is shown below. Observe that the solution to this system is given right here. Now, what we're really looking at is we said that we put this in the form of x, y, and z. Yes, x was first, y was second, z is last. So if we wrote this back out, the top one would be, well, we have 1x plus 0y plus 0z is equal to negative 1.4, yes? Well, that's really saying what? X is equal to. Now, the next one has 0x plus y plus 0z is equal to. Well, it's just telling us y is equal to 5.2. And the last one, 0x plus 0y plus z equals 16. So the answer, x, y, z, is given to us right there with this reduced row echelon form. Now, if it ever is a no solution, would be if this here was a 0 and I still had a number over here, because that bottom row would be saying everything's zeroed out. 0 is equal to a number. That would be a no solution. So this is in your notes, solving a linear system using technology. Write an augmented matrix. Enter the augmented matrix into your graphing calculator. Use reduced row echelon form from feature to rewrite the system. Interpret the results to get your answer. So this here is our system. So what would our augmented matrix be? Two, three. Okay. I'm writing that down because I'm going to pull this calculator up. Yep, you're going to need a graphing calculator. So go on and turn your graphing calculator on because we're about to start plugging this in. Yes. Okay. Are they low or are they dead? That's fine. It'll last the day because it'll start popping that up, but they'll still last a while. I can get to it after class. So the first thing we want to do after you turn it on is go second matrix. Second matrix, and it's going to be written in blue. How's it going? So go on and grab a graphing calculator. So everybody get the same thing I have up here? So almost. So we need to go second matrix, and you have this list show up, yes? Now, we want to input the matrix into the calculator, yes? So we're not going to click on this here, because we're wanting to do what to it? We're wanting to edit. So we're going to go over to edit and hit enter. So what we're doing is we're editing matrix A. We're defining what matrix A is. Now we said our matrix was a what by what? 3 by 4. So in the top we're going to have 3, enter, 4, enter. So it looks exactly like our augmented matrix, yes? Because we have the same number of zeros. Now as you type this in, you can go on and hit enter after each number, and it'll move over to the next one. So we can say 1, enter, 1, enter, 1, enter, 2, enter. And that gives us the first one. Then we have 2, enter, 3, enter, 1, enter, 3, enter. 1, enter, negative, 1, enter, negative, 2, enter, negative, 6. And make sure you're using the negative sign, not the subtraction sign. It will not let you use the subtraction sign. It needs the negative. Because if you plug in the subtraction sign, it's expecting there to be something in front of it to subtract it from. Once you get this all typed in, go on and hit second quit. And it should take you back to the home screen. Everybody get this typed in? Okay, so I'm going to go on and do second quit too. So we're back here. Now what we'll do next is we're going to go second, go back to matrix. Now if you notice now it says matrix A is a 3 by 4. It lets you know the dimensions. So if we went over to edit, it would have that also. But what we're wanting to do is we're wanting to do a little bit of math with this. And it talked about doing reduced row epsilon form. Well, if we abbreviated that, reduced row epsilon form, well, that's an RREF. RREF, reduced row epsilon form. The one above it is just row epsilon form. We don't want it in that form. We want it in reduced row epsilon form. RREF. So you should have something that looks like this here, and it's got a parenthesis. What it's asking for is the matrix. What matrix do we want to perform this operation on? We can go second matrix. And hit enter. Because it's going to call up A. It had it selected first, so it's going to pull it up. So what we're telling the calculator is to do reduced row epsilon form on matrix A. And we can go on and hit enter. Thank you. So we have this here, a diagonal ones, and this here, negative 1, 1, 2 is our answer. So negative 1, 1, 2. Because we went X, Y, Z. X is negative 1, Y is 1, and Z is 2. That's it. That is the answer for this system. Questions on this here? Second matrix. And hit enter. And then enter again. Any other questions on this here? Negative 1, 1, 2. So here, the answer to this system of equations is negative 1, 1, 2. Let's look at another one. Let's do this again. So You can leave it, because most of the stuff I know that you'll have a tendency to just want to clear it out. It doesn't affect anything. Because most of the time, even though you hit clear, if you actually press up, it's still sitting right there. So let's look at this here. We want to write this as an augmented matrix first. So in all three equations, we do have x, y, z in order. So we're good there. So our first row would be what?
2, 3, -1.
Next one.
3,
-12. And then the last one. 4. When I write my matrix, even augmented, I always write the first one, make it so it at least will fit 3. Write the first equation out, and then we'll put an end bracket on it. That way I know it's at least spaced far enough apart for the numbers. Because if it'll fit the top one, it'll fit the other 3. Okay. Now we can go back to the calculator. So we need to input the new matrix in, yes? So we can go second matrix, and then over to edit. Enter. So we have that pulled up again. Now, it is still 3, so I can just say enter. It's still 4, I can say enter. So that works well with the numbers up top. With these here in the elements, each number inside the matrix, just go on and retype them again, even if it is the exact same number, because you have to hit enter like 2 or 3 times to get it to accept the number again. So it's sometimes easier to just retype it in. 2, 3, -1, 15, 3, -9, 9, -12, 4, -3, -1, and 19. Y'all remember what we did next? Second quit. So I'll show you, and then what did we do next? Second matrix, enter to call up matrix A. If we plugged it in matrix B, we would scroll down one to B and select it, or C, or so on. And then at this point we can hit enter. And so the answer is? And that'd be our answer. All right. I know we've got more, but I feel like probably we do one more of these and y'all are probably good. You're probably good at this point. Yes. Let's look at this one, because this one's a little weird, because the second row and third row only have how many variables? 2. That's fine. 6, I think, is the last one. So let's look at the augmented matrix. So the top row would be what? 2, 5, -10. How about the next one? 6. Because the second one does not have a y, so we have to put it in as 0. Because I can add 0y, it's just 0. I didn't add anything. So the bottom one, because for any spot that's missing, we do have to put in a 0 for it. If y'all want to go on and start putting that matrix in, that's fine. I'm just writing this out so I can reference back to it. Second matrix. Edit. 3, 2. 10, 6, 0, 8, 0, 1, 3, -2. Okay. Second quit. So I'm going to show you a shortcut. So we've plugged this in twice already, yes? So what we're going to do next is we would go second matrix, pull up our REF, and then go second matrix A, yes? Don't I already have it there? So if I go up and highlight it and hit enter, it pulls it back down. Y'all have done that before with numbers where you can pull the number back down. Hit enter again. It gave us the answer because we redefined what matrix A was. We changed it to our new matrix. So it's going to call that. It's not going to call the previous one. So 0.6 repeated. Well, it's just negative 2/3. And then we have negative 34, comma negative 12. Yes? Let's do math. You all see this list? And the first one's frac, F-R-A-C. Hit enter. Enter. You see that the negative 0.6 repeated changed to negative 2/3? Yeah, FRAC is just fraction. So it's just saying whatever the number in front of it is, arrow change it to a fraction. And it'll do that for us. It'll change it from a decimal to a fraction. I don't think. Yeah, it's just going to leave it as a fraction. You'll have to go to the next one down for decimal. Now, alpha y equals. Here's our fraction, a whole number and a fraction for alpha y equals. This third one is to go from an improper fraction to a mixed number. And the last one is fraction to decimal or decimal to fraction. So the last one is F, arrow F, double arrow D is fraction to decimal or decimal to fraction. That one will switch between the two. So those are kind of nice to have here. Because we also have some functions, absolute values at top. And if we wanted to put a matrix in here, we can. But we do have to be careful with this because hitting enter, because if I go 1, enter, it's going to actually enter the function in. So if we wanted to do RREF and then manually type the function or the matrix in, we could do that also. And that's it. Well, hold on, let's not do that yet. Let's go back here. Okay. Where's my... Okay. It's right here. Over. times routine. Let's see. One. Page 45. Problems. Three through 8. 11 and 12. And then 13 through 19 odd. And that is it for